If you are interested in receiving AI8 credit or continuing education credit for this webcast, stay tuned to the end of the webcast. Before we get to the Q&A, we'll put up a link at that point that you can write down and plan to go to at the end of the webcast. We're very happy to have as our speaker today Eric Richman of the Pacific Northwest National Laboratory. Eric, please begin.
Thank you, and welcome to the presentation on the 2009 IECC Commercial Lighting Requirements. I'd like to start with a bit of background, what this code is and where it comes from. It is the International Energy Conservation Code. It provides commercial and residential provisions, but we're going to be talking about the commercial lighting requirements today. These are contained in Chapter 5 of the IECC code, which also references as an alternate compliance path the ASHRAE 90.1/2007. This Section 5 includes lighting, of course, and it covers lighting controls and power density for both interior and exterior. And there are some major changes in the 2009 version, which we will cover here as well, two of them being some daylight zone control requirements and some new exterior lighting requirements, an expansion of those exterior requirements into zone applications instead of one single application. So the IECC code compliance process here is kind of a graphic showing you the whole thing. The first box, of course, is to find out if your project must comply with the IECC. So let's look at that. Does your project need to comply? First, you need to identify if IECC 2009 is the applicable code for your state or jurisdiction. As you may know, there are lots of different versions of several codes out there that may have been adopted by your state or local jurisdiction. You need to determine if this is the one that you have to comply with. If you don't know, you can always go to a source like energycodes.gov, and it'll be able to tell you which is the appropriate code for your location or your state or jurisdiction. If the answer is yes, IECC 2009 is your code, then you need to determine if your building is either commercial or high-res residential. That's what we're covering for requirements today. And generally, if you are a commercial entity or a high-rise residential building, you will have to comply with this set of requirements, other than if you are a one- or two-family residential dwelling, or if you fall under any of the other R2, R3, R4, 3 stories or less residential type applications. Those would be found in a different section of the code, not the commercial requirements. So, assuming that you do have to comply with this code, when do the lighting and power requirements apply? And it's going to apply for anything that's an original installed lighting system or a new building. It also will apply for a new addition and will apply for a tenant build-out. If you are altering an existing system, it'll also apply. And if you have a change in occupancy of an existing building that's going to increase the energy, you also will have to comply with the lighting requirements. There are some specific exceptions. If you are dealing with a building that is on a state or national historic building register listing, or if it is eligible through documentation to be listed, it's exempted from the lighting requirements. If you are doing alterations to areas where less than 50% of the luminaires are being replaced and the power is not being increased, then you don't have to show compliance there either. And if you have a situation with dwelling units, the part of the building, the lighting within the dwelling units is exempted, as long as more than 50% of the permanently installed parts of that system include high efficacy lamps or lighting sources. And let's cover that a little bit more by describing what is meant by that. It is defined in the document itself. High efficacy sources will be compact fluorescent lamps, T8 or smaller diameter, which means T12, a common application, is not necessarily going to comply. It has to be T8 or smaller, fluorescent lamps, or lamps with a minimum efficacy, which is based on lamp wattage. And here's a table that's included. If you have larger wattage lamps, say greater than 40 watts, you have to have a source with at least 60 lumens per watt. And as it goes down, the efficacy requirement is less, of course. And what you'll find is that most fluorescent products will meet this. There will be some T12 products that won't. So you may have to be careful there when you're looking at what sources are used in your dwelling units. So getting down to the actual compliance process, the lighting section is over to the right. Compliance is based on either complying with the IECC section 505 itself, or as mentioned, the alternate compliance path, which is referenced to be 9.1 2007, section 9. There's another way to comply, which is using the building performance method. We are not going to cover any details with that in this presentation, but that is the whole building modeling that, of course, is always an option if you would like to go that path. So what's covered under electrical power and lighting? There's very little on electrical power. We will cover one item on electric metering. The majority of it is in lighting. There are mandatory interior lighting requirements, which comprise primarily required controls. There are very few specific wattage efficacy limits, mostly controls in the mandatory section. There's also an interior lighting power allowance requirement. This is the one most people are familiar with, the lighting power densities, where you're given a certain amount of wattage to use, and that's your limit for compliance. There are also exterior lighting controls, again, some required controls, and one requirement on lamp efficiency. Exterior lighting also has a set of power densities similar to interior, the same kind of format dealing with exterior applications, and we're going to cover that, of course, in detail. And then, as I mentioned, the one electric metering requirement. So starting off with the interior lighting control, basic control requirement is that each space surrounded by floor-to-ceiling partitions, basically each room or large area, must have independent lighting control. And the intent here, of course, is to allow the occupants to control the lighting in each space as needed at the use they need when they need to do it. These controls must be located in the space. However, you can have a control switch from a remote location if there's a need for that, but then it has an additional requirement to have an indicator that identifies the lights that are served. It could be just simply a listing, and some indication of status, usually a pilot light indicating whether those lights are on or off. And there are some exceptions to this control requirement. Security or emergency areas that must be continuously lighted or, of course, exempted for obvious reasons. Lighting in stairways, and corridors that are elements of the means of egress are also exempted from this requirement. There's also a separate control requirement which is called light reduction. You may understand it as bi-level control. That was kind of the predecessor of this requirement. And it basically requires that each area must allow the occupant to reduce the connected lighting load by at least 50% and in a reasonably uniform pattern. And this, of course, allows occupants to moderate their light levels, gives them more flexibility, allows them to save energy if they are of a mind to do so. The compliance of this can come in several forms. You can control all the lamps or luminaires, such as a dimming system that can dim down to at least 50%. You can have dual switching of alternate rows, alternate luminaires, alternate lamps, anything that gives you a uniform pattern down to 50%. You can also switch the middle lamp if you have, for example, 3-lamp luminaires. This would give you a 2/3, 1/3, which would comply with the requirements as well. You can also control each individual luminaire or each lamp. This would be a more expensive option, but that would comply with the requirements as well. There are some exceptions to the interior lighting reduction requirement. Some spaces where it simply doesn't make sense or is impractical to comply with. Areas, of course, with only one luminaire, there's really no practicality of that. Areas controlled by an occupancy sensor are exempted because the occupancy sensor provides, in most cases, more energy savings than a simple bi-level or manual lighting control. Certain space types where it's not practical, corridors, storerooms, restrooms, or public lobbies, there may be security issues in some of these as well, so those are exempted. Sleeping units, of course, are exempted, again, for practicality reasons, and also spaces with low installed wattage, less than 0.6 watts per square foot. Again, from a practical standpoint, that isn't as much energy savings, and therefore it's exempted. One of the major control requirements in the standard and most standards across the country is automatic shutoff of interior lighting. And this is required in this code for any building that is greater than 5,000 square feet. You're required to have auto shutoff. what is important here is to kind of define what a building is, because there has been confusion in the past. There are a couple of different phrases here: any structure used or intended for supporting or sheltering any use or occupancy. This is typically what we think of as a building, a unified structure. But a building area surrounded by exterior walls and firewalls is also considered a building for this requirement. The classic example might be a retail mall that may be on its own greater than 5,000 square feet, but each individual business entity might be smaller than 5,000 square feet. And typically these have their own electrical service. They have firewalls between each unit. And by the second part of the definition would then be considered a building. So an individual business entity less than 5,000 square feet wouldn't fall under this requirement, but any of those over 5,000 square feet would. And then, of course, like most requirements, there are a few special exemptions, sleeping units, where it doesn't make sense or might be an issue with the lights going on off automatically. Lighting for spaces where patient care is rendered are exempted for similar reasons. And the catch-all, any other area where you might endanger occupant safety can be exempted as well. How do you comply with this requirement? There are basically three methods. The first is some kind of an automatic time-of-day controller. Typically, this will be a whole building controller, might be tied into an ENCS system for the building. There are some limitations. It must control less than or equal to 25,000 square feet for each switch or each control point, and not more than one floor for each switch or control point. Or you can comply with occupancy sensors that turn lights off within 30 minutes of the occupant leaving the space. And these, if they were put in every room, would also comply. One point to make here is that you can combine these two, as you see in the graphic. You can have occupancy sensors in some spaces where it makes sense and have a whole building control switch system for the rest of the spaces. The combination works just fine to comply with the code as well. And the third option, again, somewhat of a catch-all, is if you have some other type of automatic, has been automatic signal that does this control, that would comply as well. The key here being that it must be an automatic control. There is an override requirement also for automatic control, such that if an occupant needs to come in and do some work after hours, for example, they can come in and make that work. There are some requirements for the override. It must be readily accessible, again, so occupants can activate it. It must be within the view of the lights or area that's controlled, so the occupants can see what they're actually overriding. It should be manually operated, again, for occupant use. It should have a less than or equal to 2-hour override. There's a limit on that. You must control less than or equal to 5,000 square feet with each override. You don't want to turn on lights in areas that aren't going to be used. And there are some exemptions. In areas such as malls, arcades, auditoriums, etc., where you have single large area uses, and you have a separate control, captive key or control in another part of the building, you can exempt that as well with the same kind of a 2-hour override. The override in these similar kinds of spaces can also be larger than 5,000 square feet. You can cover up to 20,000 square feet with these. So again, to reiterate, in these spaces you can have over 2-hour override, and you can cover a lot larger spaces. The one final control for scheduling is called holiday scheduling. In a lot of building types, you're required to have a separate control that will turn off all lighting loads for 24 hours and then resume. There are some exceptions where it doesn't make sense because holidays are not typically observed from building operating conditions such as retail stores, restaurants, groceries, places of worship, and theaters, which are typically operating during holiday hours. These would be exempted. Now we'd like to talk about one of the new provisions for 2009, which is daylight zone control. We need to start off with a couple of definitions. One for a daylight zone under a skylight. The simplest way to look at this is the dimensions of the skylight, and in each of the 4 dimensions, add to that the floor-to-ceiling height or the dimension to a ceiling height opaque partition that might be in the way, or 1/2 the distance to an adjacent skylight, or other vertical fenestration, whichever is least. You add these to the skylight dimension in all 4 directions, and that defines the area that is considered a daylight zone when you have skylights. Let's look at similar definition for vertical fenestration when you have windows, and this is defined by a depth and a width. The daylight zone depth in this case is assumed to be 15 feet into the space away from the vertical fenestration windows, or to a nearest ceiling height opaque partition, which of course would block the light, whichever is less. The width is then going to be the width of the window plus 2 feet on either side, or the width of the window plus the distance to, again, an opaque partition, or the width of the window plus half the distance to the next daylight area or area with skylight or vertical fenestration, whichever is least. So that defines the 2 daylight zones, one for skylight, one for vertical fenestration. The actual requirement for these daylight zones is that you must have individual control of the lights separate from the general lighting, and this allows occupants then to control that lighting and make use of the daylight. There are some special cases if you have contiguous daylight zones adjacent to vertical fenestration. In other words, a row of windows. You can control larger areas with a single control if that zone or the areas in that zone do not encompass more than 2 adjacent orientations. So you could have a north and an east corner, for example, all in the same control, but areas on the north and the south could not be controlled with the same control for obvious reasons. If you have daylight zones that are under skylights and are greater than 15 feet from the perimeter, then these must have a separate control as well from the area that's daylit with windows on the side of the building. Must be a separate control. There are, of course, some exceptions. If you have a daylit space that is enclosed by walls or ceiling height partitions and contains 2 or fewer light fixtures, then you're not required to have a separate switch. Again, from a practical standpoint, that doesn't make a lot of sense. And one other note, these can be manual or automatic controls. There's no specific requirement as to what kind of control, other than it has to be separate from the general lighting, so occupants can affect them differently when there is daylight available. There is also a separate control requirement for sleeping unit lighting. This applies to all sleeping type units, hotels, motels, boarding houses, etc. There must be a master switch at each room or each main room entry. So if you have a hotel room that's just one room, typical configuration, you have to have one master switch near the door. If you have a hotel room with suites within it, or suite with rooms within it, you can have a switch at each individual room. The idea here is that each of those switches would then control all permanently wired luminaires or switch receptacles, with the exception of bathrooms. Those do not have to be controlled. And this, of course, allows the occupant to turn off all the lighting in the space as they're leaving the room without having to go back into the room to turn off individual lights. Another requirement for tandem wiring, and this is intended to eliminate the use of magnetic ballasts, which are still used in some applications today, eliminate the use of those when they're driving single lamps. So if you look at the example there, if you have a couple of 3-lamp luminaires that have 1 to 2 lamp ballasts, which is a common configuration, at least for older technologies, you want to tandem wire the 2 individual lamps so you do not have a magnetic ballast driving just one lamp. That's the basis of the requirement, and the exceptions, of course, feed to that in other words, telling you what would work in order for you not to have the tandem wire, which are going to be common applications. Where you have high-frequency electronic balance, you don't have to deal with this requirement. If you have luminaires that are on an emergency circuit, again, those are exempted. And if you don't have an available pair, those are exempted. Again, this only applies to magnetic-type ballasts when you have a 1 or 2 lamp ballast driving just one lamp. Not a very common application today, but sometimes you will run into it. One other specific requirement on exit signs, there is a limit of the wattage. It must not exceed 5 watts per side, and there are lots of choices out there that meet this requirement pretty easy to match. And that basically ends the interior control and miscellaneous requirements. So now we'd like to move on to the major requirement in the code, which is the interior lighting power density limits. And most of you are probably familiar with these. It's a requirement that your connected interior lighting power must not exceed the allowance that you're given for interior lighting power. So it's fairly straightforward in that you have to calculate what your allowance is and calculate what your proposed wattage is and make sure your proposed wattage is less than the allowance. So like it notes here, you calculate your power allowance based on a building area type with some additional allowances. You calculate your proposed wattage. You have to follow some wattage rules when you do this, and we'll discuss those. And there is some exempted lighting as well that you don't have to count. Then you compare these two numbers, and you'll determine if you comply or not. So let's go into that with a little more detail. The requirement is based on building area type for your allowance. And what you see here is the actual table from the code that has each of the available building area types, and there are 32 of those, with their watt per square foot allowance. What you need to do is find your building or building areas within this table. If you don't have an exact match, you're going to want to try and find the closest match. And in some cases, you may have to talk with the building official to determine what would make sense and what they would accept or what's reasonable. Once you've chosen your building area type from that table, you can then apply an allowance to it, a wattage allowance. You need to remember, however, that that building area includes all of the common space types you would find for that. So in this case, a simple example of an office building area is going to include some corridors, restrooms, lobby, office spaces. You don't identify those separately. That becomes part of your building area type. If you had another building area type, say a restaurant, it would include some of the same types of spaces as well as cooking facilities and dining facilities. So it's done by building area type, not by individual space. And then, of course, you identify the watts per square foot lighting power allowance, multiply it by that square footage to determine what your total wattage allowance is. Here's an example again with an office, fairly straightforward, 200,000 square foot office building. It's given an allowance of 1 watt per square foot. It's just simply 1 watt times 200,000. You have 200,000 watts to use for your compliance limit. If you have a multiple occupancy building, the example here being a museum with, say, a retail associated with it and a cafeteria, then and because all three of those building area types are included in the table, you need to calculate them separately. Now, if you wanted to, you could try and say, well, this is just a museum. But in this case, museum, retail, and cafeteria are all included in the table, so you do have to use those. A museum might be a common space type, including a little bit of retail in some cases, but typically it wouldn't include retail and a cafeteria. So it makes it clear in this case you have to separate them. The simple rule is if part of your building as a general building area is included as a building area type on the table, you must use that and calculate using that building area type. So in this case, you calculate your allowance for each of those three areas, add them together, and that becomes your total allowance. So again, here's a similar example. You have a museum at 40,000 square feet at an allowance of 1.1. Similar case for cafeteria and retail. You calculate the individual wattages, add those up, and you have a total allowance for the entire building. There is one part down in the end of the table that wasn't shown, but is shown more expanded here, which is the one allowance that you're given for additional power for retail spaces. And in this case, if you do have retail display lighting, and it's very important to understand that this is additional lighting, it's in addition to your general illumination in the space, it's installed specifically to highlight merchandise. Typically it's going to be an adjustable type of lamp that is aimed at and specifically only lights merchandise. A general rule of thumb would be if you turned off all of this additional lighting, you would still have a space that's generally illuminated. These are just additional lights. If you do have these, you are given an extra allowance, and it starts with 1,000 watts as a base load, and then you get to multiply by each retail area a separate allowance. And you'll see there are 4 retail areas, 4 allowances. The first 2 are allocated at 0.6 watts per square foot, retail area 3 and 4 at higher values. And there are definitions here for what each of those areas is. And retail area 1 is basically anything else that's not listed in 2, 3, and 4. And for 2, 3, and 4, you'll see there are specific allocations for different types of merchandise. If that's the type of merchandise you have in a certain part of your retail store, that's the retail area that it's defined as, and you have an allowance that's given for that. Again, you need to make sure that this is only for highlighting allowances, highlighting merchandise, not for general illumination. There's also an exception here at the bottom that notes that if you have merchandise that isn't included in retail area type 2, 3, or 4, or in areas 2, 3, or 4 that you believe should be included in there, as long as the building official accepts that addition, you can use those 2, 3, and 4 allowances. So now that you've identified what your allowance is, you need to figure out what your connected lighting power is. And this, again, is the sum of the wattage of all your proposed connected lighting power. And this must include your overhead lighting, it must include your task lighting, and it must include decorative lighting unless it's exempted elsewhere. We'll talk about those exemptions. And note also that your wattage must be calculated based on actual power draw, not just a nominal lamp rating. Here's an example of connected lighting power, the rules for connected lighting power. You must calculate your screw lamp holders. These will be your typical Edison-based. So let's look at how that calculation is to be done. There are some rules that have to be followed when you're calculating your installed wattage. For screw lamp holders, the typical Edison-based product, can lights, etc., it must be the maximum labeled wattage of the luminaire. So whatever the labeling is that came from the factory, etc., is the number you are to use. You cannot use the simple wattage of a bulb you may or may not be putting into that fixture. It's got to be the maximum labeled wattage of the luminaire, because that is the wattage that may at some point, either initially or down the line, be installed into that fixture. If you have low voltage lighting, it's going to be the rated transformer wattage for that low voltage lighting system. If you have line voltage track, you have 3 options. You can install the specified wattage with a minimum of 30 watts per linear foot, or the wattage limit of a system circuit breaker that set of track is on, or the wattage limit of other permanent current limiting devices. And these are commercial devices that are permanently installed on a piece of track or a set of track. You can use either of those to calculate the line voltage track. If you have other types of luminaires and lighting, it's the manufacturer's rated wattage of the lamp plus ballast. You have to include ballast when you have a lamp plus ballast system. So these are the rules you have to use to calculate your installed lighting power. And of course, as we mentioned, there are exemptions to the installed power. We're not going to go through each of these, but there's a fairly long list of specific applications that are exempted from the calculation. And they include areas or applications, for the most part, like professional sports, arena playing fields, sleeping units, as we mentioned before, are exempted. Other areas which are going to be quite varied and are for other purposes other than perhaps general illumination, such as casino gaming areas. Task lighting for medical purposes is, of course, exempted. And a whole host of other applications where, again, it's not necessarily general lighting or it's for a specific purpose that really should not be controlled separately. These do not have to be counted when you're calculating your proposed wattage. So what if you get done with your calculation and your proposed design does not meet code? There are several things you can do. Certainly the first thing you should do is check your calculations. Did you pick the appropriate building area types? You want to make sure you've got the right numbers for your allowance. Did you pick the actual lighting equivalent wattages? Did you follow the rules and calculate according to what you're actually going to put in there? And make sure specifically that you follow the list of exemptions. You don't want to have to be counting any lighting that is not required to be included. You also want to look at your design. Do you have reasonable luminance levels provided? You may find in a lot of your applications that your places are overlit. This is not necessarily a fault anywhere, but it's commonly done. You want to look at whatever recommendations, such as the IES site level recommendations, and make sure that you are on par with what you actually need and not more than you need, because that will, if you are lighting to above typical recommendations, which is what the code is based on, you will find that you're going to have a lot of trouble complying with the code. Have you used the most efficient light sources? Again, the code is based on the use of generally efficient light sources, and so if you aren't using those, then again, you're going to have trouble complying with the code. If you still are having trouble, you might want to consider using the alternate standard 90.1 2007. It does offer potentially some other flexibility in that it has a space-by-space method that may make it a little easier for you to show compliance. It might be worth trying as well. And as a final step, of course, there's always the whole building or building performance method that's allowed in IECC 2009, which essentially models the energy use for your entire building. And that's one way also of showing compliance. You may find that's the easiest. One note on using the alternate 90.1 2007 method, the current 2009 IECC requires that if you go to that method, you must use it for all disciplines, envelope lighting, mechanical. You cannot just do it for the lighting, say, and then do IECC for mechanical and envelope. It has to all be done either to 2007 90.1 or to IECC 2009. So that basically covers the interior lighting requirements. Let's look also at the exterior lighting requirements, and let's start first with controls. If you have any dusted-on lighting or typical parking lot type application, you must have either an astronomical time switch or a photosensor to do that control automatically. If you have any other night lighting that isn't strictly dusted on, you can either control it with an astronomical time switch or a combination photosensor and time switch. That's your choice, provides a lot of flexibility, but in either case, it's going to be automatically controlled. And all time switches must have a 10-hour battery backup, so if there's a loss of power, you're not going to lose the control requirements right away. There's also one exterior efficiency requirement, and that is that all building grounds lighting, if it's over 100 watts, must have a source efficacy of at least 60 lumens per watt. And if you look at this table of general lighting sources, you'll see that that 60 lumens per watt is going to restrict the use of incandescent, halogen, and some compact fluorescent. But again, this is for luminaires over 100 watts. So you're probably going to find you're going to be using either a linear fluorescent or an HID, like a metal halide product. And in most cases, those will meet this requirement. You may find some that don't on the lower end of those product ranges. So again, you'll have to be careful. But for the most part, it's going to eliminate the use of incandescent and lower-end compact fluorescent products on the exterior. And that's essentially the intent of that requirement. There are some exceptions to that if that luminaire or light is controlled by a motion sensor, which again provides about the best energy savings you can get. It would be exempted. If the light is used for any of the purposes in the exterior lighting power allowance exception section, which we will go over, it is also exempted, of course. And if it's an approved light for historical, safety signage, or emergency consideration, then it's also exempted from this requirement. So exterior lighting power limits, similar to the interior lighting power limits, there is a parallel set of exterior lighting power limits. These are applied not so much on an exact space type, but more on an application or surface type. But the process is the same. You calculate your lighting power allowance based on these functions, spaces, and applications, and then you calculate the proposed connected lighting power that you're going to install on the outside, again, using the same wattage calculation rules, and looking out for any exempted lighting that you don't have to count. And then just like with the interior, you compare these two values, and you need to make sure that your proposed wattage is less than or equal to the allowed wattage. So the exterior lighting power limits, what's covered under these? Essentially, any exterior application is covered. The table tries to be inclusive. and that it has a section for everything you might encounter on the exterior. And again, this is only for lighting that is powered through the building itself and associated with the building. It is divided into two separate types of applications, one called tradable and another called non-tradable. The difference, of course, being that with the tradable applications, just like with the interior lighting credit allowances, you can swap wattage from one application to another. It's the total wattage used for those applications that's important. Non-tradable surfaces are use it or lose it. They're going to be special applications with special allowances, and you cannot trade from one to another. You either use it for that application or you don't get that allowance. So let's look at that in a little more detail. Tradable surfaces, this is a list of the basic tradable surfaces. These are going to be the more common applications in most building exteriors: uncovered parking lots, walkways, stairways, pedestrian tunnels, main building entrances, other building entrances, canopies of pretty much any type, freestanding end entrance, open sales areas, and street frontage. All of these are tradable surfaces. So, for example, if you didn't use all the wattage that you were allowed for a parking lot, you could apply some of that to a pedestrian tunnel or canopies, for example. And the non-tradable surfaces, these are the non-tradable surfaces in the table, starting with building facades, and it includes specific applications, like I mentioned, such as automated teller machines, very specific application, entrances and gatehouse inspection stations, loading areas for law enforcement. These are related, again, to security issues. Drive-up windows, again, a very specific application. Parking near 24-hour retail entrances. These are, again, special applications. A lot of times they're driven by security issues, and they are considered non-tradable. One thing with the requirement that also needs to be dealt with is the application of an exterior lighting zone. The requirements are based on what kind of exterior lighting zone your building is in. The realization is that different areas of where your building is located have different lighting requirements. If you're next to a lot of exterior lighting, your lighting, because of contrast or visual needs, is going to have to be higher. If you're in low light ambient conditions, you don't need as much light. So there are 4 defined zones here. The first one is for those low light areas, national parks, state parks, basic forest land or rural areas where there isn't much light to begin with, so you don't need as much light for contrast and visual capability. Area 2 is going to be a very common application for a lot of buildings, and these are basically residential zoned or neighborhood neighborhood business district zones. Light industrial might be included in there as long as it has limited nighttime use. Mostly a lot of residential and neighborhood business areas. Skipping over number 3, going to number 4, this is going to be the high end of the scale, very high activity commercial districts. These are typically going to be located in major metropolitan areas, inner cities, etc., with a lot of exterior lighting to begin with, and so the lighting needs are going to be higher. This area, because it is the top of the scale, would typically be designated by your local land use planning authority. If they agree that you're in Zone 4, then you can use that allowance. Going back to lighting Zone 3, that's all other areas in between, and this is going to cover a lot of commercial areas that are not within a residential zoning space and not within a inner city type environment. This will also be a common application. So once you determine which zone your building is in, you're then able to go to the table and actually pick your allowance. And this is the first part of the table, starting off with the tradable surfaces, but you'll notice at the top there's a base site allowance. So depending on whatever zone you're in, you do start off with a certain number of watts just from the beginning because you're going to need a certain allowance for different parts of exterior lighting. And the allowances are different, of course, because of the zoning. The base allowance is there because there's a realization that if you have particularly a small building, you're not going to be covered potentially by a lot of the allowances per square foot. You're going to have somewhat higher needs simply because of what's considered the economies of scale. You have a smaller building. You don't have as much square footage to get the wattage you might need. So you start off with a base allowance. You then pick each of the applications that you do have, and you get an allowance for each one of those. And just like the interior, you have to have that area type, or in this case application type, to get the allowance. So if you do not have any parking area that's lighted, you don't get any allowance for that application. You only get an allowance when you have that particular application, and this table should cover each of those. So here's a set of the tradable surfaces. You'll see that in general the allowance goes up as you go from Zone 1 to Zone 4, recognizing the fact that in Zone 4 you need a lot more lighting for most applications. Here's a second part of the table that covers the rest of the tradable surfaces, and again you'll see that for the most part they start low in Zone 1 and go up to Zone 4. In one case here, for example, outdoor sales, street frontage, there's no allowance, and that somewhat recognizes the fact that in Zone 1 you're probably not going to have any street frontage, but even if you do, there's no allowance given for that. The next section would be the non-tradable surfaces. These are the use it or lose it. And in these you'll see that a fair amount of the time the allowance doesn't change. And this is representative of the fact that a lot of the non-tradable surfaces are based somewhat on the fact that there's a security issue with some of these applications. So there are requirements other than the energy code that specify how much light is needed, and so it stays the same regardless of whether your location, wherever your location is. For example, an automated teller machine that's based more on security requirements than it is on lighting requirements in various zones. So again, once you've calculated the allowance for each of your applications, you sum that up and that becomes your allowed wattage. Now, as we mentioned, there are exemptions here that you don't have to use when calculating your installed power. Here's a listing of them. Again, won't go through each of them in detail, but they are similar in their application to the interior exemptions. There are a few here, of course, that are specific to exterior, such as theme elements in amusement parks, lighting for industrial production, things of that nature, public monuments, registered historic landmarks. These you want to make sure you don't count as part of your compliance requirement. So once you've added up all of your wattage, you've compared it to your proposed. If you aren't meeting the code, what do? Again, first thing to do is check your calculations. Make sure you've applied the appropriate surfaces, that you've claimed all the allowances you can get. Make sure you're using the actual lighting equipment wattages, again, based on those rules. And look at your design. Did you use reasonable exterior luminance values? Again, the IES provides exterior luminance recommendations. If you're well above those, then you're going to have trouble meeting the code. And just like with the interior, if you aren't using efficient light sources, you're going to have trouble meeting the code as well, because the code is based on reasonable light levels, based on IES recommendations, and efficient light sources. So, and if that isn't working, you might want to try the 90.1 2007 standard. It is essentially the same requirement, so you probably wouldn't see any difference there, but it's always an option if you want to try that. But in the case of exterior, the requirements currently are exactly the same, so you wouldn't see any difference. And as a final option, you can use the total building performance method. That's always available for use. One last requirement on metering, and the requirement here, of course, is for residential type facilities. Each dwelling unit needs to have a separate meter. And the idea here, of course, is to allow the occupant the capability of having the data they might need to make good decisions that, of course, can lead to energy savings. And that completes the presentation for today. Thank you.
The U.S. Department of Energy would like to thank all of you for your attendance today.